Hello all, welcome back to Quest Zero. Continuing our sessions on projection of planes, today we'll continue with one more triangular lamina whose resting condition is different from the previous problem. The question statement is as follows: a triangular plane lamina of sides 25 mm is resting on HP with one of its corners touching it, such that the side opposite to the corner on which it rests is 15 millimeters above HP and makes an angle of 30 degrees with VP. Draw the top and front views in this position. Also determine the inclination of the lamina to the reference plane. So unlike the previous problem, this problem we have one of the corners of the triangle resting on HP instead of an edge resting on HP. So what we'll do is, as usual, we will start by drawing the XY line. For the length of the sheet of paper with a HB pencil with normal pressure applied. Name them X, Y, VP, HP. Now, if you observe the image that I put up, when it is resting on HP, the first position, we make the entire planar lamina to lie on the resting plane. So, resting plane is HP. So, we'll make the entire lamina to rest on HP, but we'll make sure that one of the corner is on the right side of our view, such that in the further positions, the corner will always remain in contact with HP, thereby signifying that it is lying on HP. So, initially, we'll draw the diagram in the top view, that is where the triangular lamina gets projected. Top view is, again, it is a 25 mm triangle. It is again an equilateral triangle. He says triangular plane lamina of sides 25 millimeters. We'll consider this to be an equilateral since there is no other dimension given. So again, this line should be parallel to your XY line and perpendicular to, it should be perpendicular to your XY line, and you can start drawing it at 1.5 centimeters away from the XY line. So I'm using a 2B pencil directly. Let's say from 1.5. Yes, this is the edge of the triangle. Since the corner resting condition is given, we'll make sure that the corner lies on the right side instead of the edge, unlike the previous problem. Construction, again, equilateral triangle. Take the measurement. Cut an arc from both the endpoints of the edge that you have drawn. The intersection of these arcs will give you the resting corner or the third corner of the triangle that is being drawn. So this is, I'll join this. Naming them Again, I'll go with the anti-clockwise notation. So this is A. This will be B. This is C. Now, dimension the line should be for 25 mm using your 2H pencil or the HP pencil where the pressure is being applied very lightly. Some distance away from the edge. Filled aroma is 3:1 ratio. The number will be written with a 2B pencil, 25. Now, since it is entirely resting on the HP plane, when you view it in the front view direction, the projection that happens on the VP plane will be on the XY line and it will be a single straight line. The projection will not be in 2 dimension, it will only be in a single dimension, which is nothing but a straight line. So whenever you are drawing it in a 2D sheet of paper, always remember that this is the direction of your front view. Top view will always be from VP towards HP. For front view, it will be from HP towards VP. This is the viewing direction. Okay. So I'll take the projection lines till the XY line. Okay. Both the projection lines from A, B and C should be parallel to each other. Now if you observe, from A I am drawing a projection line. From B, the projection line will coincide with the BC edge. Since the priority is given to the visible lines or visible edges, BC will be taken priority and will not overlap or overwrite the projection line on the visible edge. So from C, it will continue till XY line. That is what we have marked. Naming them, from this direction when you view, B will be visible. So B dash. C will be exactly behind B. Hence, it will not be visible. C dash will be written in brackets. A dash is at this end. Okay. So, with your 2B pencil, darken the segment on the XY line on which the projection lines intersect. So this is A dash, B dash, C dash. Okay. Next, mark a random point. The next condition he says that the edge opposite to the resting corner, it is at a position which is 15 mm above the HP plane. So the side opposite to the corner on which it rests. For us, A is the corner which is resting. So the side opposite to the corner which it is resting is BC. So BC, they say from the question that it is 15 millimeters above HP and it makes an angle of 30 degrees to VP. So the next condition is, as I told you, for the second position, we will look for relation with respect to the resting plane. So which is the resting plane now? HP is the resting plane. Hence, in the HP plane, you have drawn the triangle to the true shape and size. Now, the condition with respect to HP is 15 millimeters above HP, the edge BC will be present. So what we'll do is, from XY line, measure 15 mm. So right here. So this is 15 mm, and at this 15 mm line, draw a locus, very small locus. Everything with a 2H pencil or a HB pencil. Draw a locus. Now, using your compass, measure the length from A dash till B dash C dash, and at a random point on the XY line, place your needle end of the compass, cut an arc such that it intersects the locus line that you had drawn. Okay, so this point, the intersection point will be B dash C dash. The measurement will be taken in the compass from the front view of the first position. If you observe the image that I had displayed, the corner will always rest on HP, hence in the front view the corner will be touching XY line. This point is the resting corner on HP, which is nothing but A dash, and this point is B dash C dash. So connect A dash to B dash C dash with a 2B pencil. Okay. Dimension the height, which is 15 mm. Okay. Now, when you view from the top, it will no longer be an equilateral triangle. The length of all the edges would have reduced. AC, AB, CB, all the edges will be reduced because none of those edges are parallel to HP. So in order to obtain the positions of A, B and C in the top view, we will draw projection lines from B dash C dash of second position, front view, and will make it intersect with the B and C projection lines from B and C of top view of first position. So this will be with your HB pencil very lightly, or use a 2H pencil. From C as well, a projection line. Similarly from A, we'll draw one more projection line. And we'll intersect that with the projection line from A dash. Okay. So this intersection point is A. This is C. This is B. Now connect all the three lines. The edge BC is parallel to XY, hence the same dimension is retained, but the edges A and C are reduced in its length. So pardon me for the previous explanation saying that all edges have retained the same length. The only BC has retained the same length. AC and AB has changed in its length. So this completes the second position. So for the third position, we look for the condition with respect to the other plane on which the lamina is not resting. So the plane on which it is not resting is VP plane, and the question states that the edge opposite to the corner on which the lamina rests is making an angle of how much? 30 degrees to VP. So 30 degrees to VP is nothing but we need to create a 30-degree line. So select a random point. We are going to rotate this triangle to the anti-clockwise such that BC edge makes 30 degrees to VP. So in order to do that, let's take a point sufficiently away from the second position. Mark 30 degrees. Here it is 30 degree. Connect the markings with a 2H pencil, denoting that a 30-degree line has been drawn. Now we need to rewrite this same triangle by rotating it by 30 degrees. In order to do that, measure BC from the second position, top view. Make sure that you don't start very close to the XY line, because your A of the triangle should not cross the XY line. So what I'll do is I'll draw it sufficiently away from the XY line. Okay. Now this point is B. This point is C. There is no hard and fast rule that it should be rotated anti-clockwise. If you choose to, you can rotate this clockwise and also keep. That is left to you. Unless it is specified in the question, you have the liberty. Now measure the distance from BA, from B, cut an arc to obtain A. This is what I said. This position of A should not cross the XY line. Hence I took it sufficiently away from the position. Now from C to A, measure, cut the arc. The intersection is point C. Sorry, point A. Connect all these points with a 2B pencil, marking the triangle's top view in third position. Okay. Now the view that you get, I'll mark the angle as well. This is 30 degrees. In order to obtain the front view, we need to draw the projection lines. To draw the projection lines from C, it should intersect the projection line from the second position of B dash C dash, that is the front view. So whatever locus line you have drawn, you can take the projection line from B dash C dash. Okay. Similarly from C, okay, and B as well. There is a very small distance from B and A. The lines should be parallel to each other. And from A as well. Let me denote these points. So this will be point C dash. This will be point B dash. This will be A dash. Don't write it below the XY line. It needs to be written above the XY line. So you can construct the triangle first and then name the final corner. Use your 2B pencil for the construction. Okay. So this is A dash. The question also asks the angle at which the plane is inclined to HP. We obtain this solution from the second position. In the second position, it gives us the inclination of the plane with respect to HP. So what is the inclination? So it is 40 degrees. I'm getting it as 40 degrees. This is, for me it is 40. The exact solution will be slightly different since the parallel and perpendicular conditions of all the lines will deviate a little since I am not using any drafter. This is 40 degrees to me. So that gives the solution. So this completes the entire solution for the given problem. We will continue our sessions on projection of planes by taking a different geometrical entity or the same geometrical figure with one of the parameter changing its length and an angle given to that particular change in length parameter. So see you all again. Until then, subscribe, like and share with all the interested people. Thank you.